We have built a VR simulator to help design robots for human residences, particularly to increase the independence of elderly persons living alone. The simulator lets us run experiments to study how humans perceive robots, under what conditions a robot makes someone feel intrigued or alarmed or unconcerned. Our improved understanding of perception then lets us improve the robot's appearance and behavior in the simulator before we graduate to experiments with robots in the real world. Other studies of emotional interaction have concentrated on humanoid robots, particularly robots with facial expressions. We are extending this to non-humanoids, which are the vast majority of robots. The detailed residence is rendered with the Unity engine and viewed with a head-tracked Oculus Rift. Audio corresponding to flight maneuvers is resynthesized from pre-recorded sounds of an actual quadrotor. Flight dynamics using L1 adaptive control run in MATLAB and Simulink. Through menus operated by a Leap Motion hand tracker, the human subject commands the quadrotor to fly to various rooms, that is, Unity waypoints, along pre-computed paths that avoid collisions. The waypoints connect with the Simulink path-following algorithm through a Python bridge. To provoke different emotional responses, the flight path is varied through standard Laban movement parameters, how much the flight looks direct, sustained, light, or flowing. The subject's emotional reaction to the robot is measured with a heart rate monitor, EEG sensors, and head tilt as reported by the Oculus Rift's own IMU. Head tilt, forwards or backwards, is a quick measure of interest or discomfort. This measure of emotion is then refined with the other biometrics. Choosing VR is letting us quickly and agilely vary our initial trials, robot size, Laban movement parameters, number and kind of waypoints, and so on. Experiments like this often hope to measure many more parameters than are possible with only a few dozen human subjects. Happily, VR lets us constrain and bound this combinatorial explosion before we proceed to the slower and costlier stage of building and flying physical robots.